Okay, so the next presentation is from a leading equipment maker, Leadmicro, which really made a big difference first in PERC and then right now changing the game of TOPCon. And Leadmicro is already looking into the next generation technologies. So we have Dr. Wei-Min Lee, who is CTO of Leadmicro. He is going to talk about the progress in developing production equipment for perovskite cells already. Hello, Dr. Lee.
Yeah, hi, Shwana. It's thank you for inviting me again in this forum. And so to catch up the time, I will start with my presentation. Let me see how do I share these ones. Okay, can you see my presentations already?
Yeah, just you have to go into the full screen presentation.
Great. All right, there we go. Hello, everyone. It's my pleasure to have these opportunities to introduce some of our recent work especially for perovskite cell equipment development work from Leadmicro. And so my title is Progress in Developing Production Equipment for Perovskite Cells in Leadmicro, in fact. So I will start with this page. This is Fraunhofer ISE's roadmap. What we see that the silicon-based cells are closing to the theoretical efficiencies, and to further continue this efficiency drive, and we will have to look at the tandem cells. I think this delivers very, very clear message on that. And well, this is also a chart everyone knows. So basically for the perovskite, the development is really fast in the past few years, and now we are seeing very good progress in perovskite cells from all over. And here I summarized some of this champion cell development, but I added the title of from lab to fab. So basically, many of these high efficiency cells are from lab scale. From the fab scale is still very, very little. Predominantly, this for the tandem cells, multi-junctions, Oxford PV and LONGi recently all have developed some of this very good cell on that. Here, I'm sorry that I did not put the GCL cells there for the for the single junctions, because I thought this Dr. Fan, he will definitely provide some detailed information, but next time I will put some additional information on I think that for the fab development, GCL's work is fantastic as well. So from Leadmicro, we are a ALD as a core technology, this equipment company. So I'm looking at the ALD's application for perovskite cells. And when you look at the typical perovskite structure, we actually have identified several applications. Some of them is just right now is working with a customer. Some of them are still in the R&D side and probably never going to be realized. For example, we worked with our industry customers for a few of these very typical application. One is encapsulation. Of course, everyone knows perovskite stabilities and sensitive to the moisture. So encapsulation is definitely one of the very important applications for ALD. And electron transportation layers or hole transfer layers, these two are currently There are PVD technology to work on that, but we also see a lot of research on ALD for these two layers. And in fact, even ALD is, there are some research work started using ALD for perovskite materials as well. I think this, we are working on this research, but probably still takes a lot of time and may never be realized for the industry scale. I don't know. But anyway, these fundamental studies we are working on. And of course, transparent conducting oxide are one of the important aspect. I think that as ALD suppliers, and we are looking at the possibilities to have some technology breakthrough. Okay, I get some, these are just some literature result on ALD applications. What you see that in many cases, ALD really shows very good potential for perovskite cells applications. For example, in this case, tin oxide for the electron transfer layer, and as well as the buffer layers for the tandem perovskite tandem cells applications. This is a fantastic idea, basically. And of course, tin oxide or even aluminum oxide are studied for this moisture barrier applications. So these are just the literature work, which you can see very broadly referred to, and I especially take this opportunity to thank this Dr. Tan from Nanjing University. They did the really fantastic work on exploring ALD capabilities for this perovskite cells. And we are doing lots of work on ALD encapsulation. We use aluminum oxide, tin oxide, and we are developing titanium oxide, and in future we're planning even silicon nitride, this type of encapsulation applications for perovskites. Here I just also, this is somewhat a little bit repeated, but anyway, there are many groups are studying. I think ALD is very good applications, for example, for electron and hole transfer layers. Here is examples on the hole transfer layer. One of these detail is that, for example, to develop ALD nickel oxide or cobalt oxide, the precursor is still one of the challenge, because perovskite material itself, it doesn't allow high temperature ALD processes, so we have to find some good process which can perform at a low temperature. Of course, on the other hand, if the structure is inverted structure, which if this for the sheet type perovskite cells, and it may tolerate the high temperature materials. So from both sides, from both front, we are doing lots of research work to develop some of this low temperature as well as the high temperature materials. Okay, and here I would like to introduce some of our Leadmicro's current work. And basically, many of you may already know that we have our thermal ALD for silicon-based tandem cells already in customer side. In our tier 1 customer side, they work on this perovskite silicon tandem cell, which is 160 times 160 milli wafers. And what we see recently, there is some news on such kind of tandem cells. The efficiency is already reached above 28% or 28.6%. And we also worked on the domestic with the domestic tier 1 customers with their single junction cells. What we see, this is not a large area, I have to mention, but it's at least 300 times 400 milli, such kind of large area cells, and we can see that their internal result is already above 30% conversion efficiency. And how do we do that? We currently are working on 3 types of products. And for the tandem cells, currently most of our work is focused on the batch type of ALD process. And of course, we have both R&D type of systems as well as production systems. This is a silicon-based tandem cell. This is very easy to understand because our batch type of ALD is mostly used in the PERC and TOPCon, and basically also XPC cells for the passivation. But on the other hand, for the single junction perovskites, it requires large substrate, either on glass substrate or flexible substrate. We actually have developed both substrate products. For the glass substrates, currently our work is we have demo capabilities of 1.2 times 1.5 meters these thermal ALD systems. And for the flexible substrate, we have a rotorose substrate which can manage wet-wise at 1.5 meters. Here is the basic sum of this. I'm terribly sorry, some of these specifications are in Chinese, but I have this title on that one, which I can just explain it. One of our R&D type of batch ALD reactor is called the Qilin reactor. And what you can see that we have very, very good tin oxide process. We already established SPC chart, a very, very stable SPC chart for this type of tin oxide process. And this is, I have to say, it's used mainly by our customer for their R&D, not even this pilot production. But from here, what we can see that the ALD tin oxide can be very, very stable in the batch processes, which I think it would be very good for the perovskites, silicon-based perovskite tandem cells. The good thing is that the process is stable and the uniformity is also very good. And for such kind of small tools, it can handle 150 wafers per batch. 1,500 wafers. Sorry, for the R&D tools, it's 50 wafers per batch. So in terms of inline our thermal ALD, we currently are developing the products which have a 1.2 times 2.4 meters, such kind of large substrates. We have a series of products available for our customer. And we also offer the complete tool with this loading, unloading, and vacuum loader, and also this preheating process and unloading systems. We offer the complete this ALD inline tools for this type of application. And these ones mostly we worked with our customer on tin oxide layers. And here is our tin oxide performance, which I think that with such kind of a large scale, the performance is very, very good. So our within wafers uniformity is very good, and especially its challenges wafer to wafer. Or the area to area uniformities. So because we cannot measure the large glass sheets tin oxide thickness. So we use the silicon wafer as a reference to measure the tin oxide wafer thickness, uniformities. So what you can see, this is really excellent. We can have such kind of in large 1 by 2 meters large substrate. We can reach below 5% of this area uniformity. This is also this process stability is very good at the moment. And of course, we also work on this flexible substrate, which I think that for thin film solar cells is also critical. And this is, we have this 800 meters, this flexible substrate. We worked on the, in fact, encapsulation layers on that. That is our, this patent technology for this high water permittivity encapsulation applications. What you can see that we can reach down to 10 to -3 grams per square meter per day. This water or moisture permittivity, which is excellent result across 1.5 meters back. And last but not least, we have this KF batch thermal ALD, and many of you already know that these ones are used at least for pilot production for perovskite silicon tandem cells production. Which we are very, very proud that we are the first to provide this type of large-scale processes. For the M10 wafers, we can do 2,500 wafers per batch. This kind of production definitely it's already there. I quickly give a short introduction for Leadmicro. We established in year 2015, but in fact today is 20. So after we have our license on the Christmas Day 2015. So next week will be our 8 years anniversary. So it took us 7 years to go for the IPO public in the Shanghai Stock Exchange. So what you see here, this is our new building, new facility. We have moved to our new facility. Our core business is semiconductor, PV, and new energy refers to the lithium-ion battery and the fuel cell, and as well as the flexible electronics. So for the PV industry, we have been marketing our ALD-enabled photovoltaic technologies. From here, you can see from the PERC to TOPCon to HBC, and even for the tandem perovskite-based silicon-based solar cells, we have complete production tools for this type of application. And we are even working with our customers on heterojunction solar cells with the ALD technology. And so during the past 7-8 years, we have accumulated almost all the major PV solar cell manufacturers are our customer. We have delivered more than 500 gigawatt capacity ALD systems already. And in terms of the system itself, we have delivered more than 1,000 systems, ALD systems, which is pretty impressive to my, personally, I feel it's very impressive work by our team. So we have been mostly working on the ALD, PALD systems. Here are a series of our products. We have a KF series and the ZR series, XH series and HY series. These are abbreviations of this Chinese light-related gods name, Hua Fu, Zhu Rong, Xi He, and Hou Yi. So we are very ecstatic that these ancient gods can help human and society to achieve the new height, use the solar energies. And currently, together with the lead group, we are probably the only group which we can provide the turnkey solution. Many of you know that we have delivered multiple gigawatt turnkey solutions to our industry for the TOPCon. So with our lead group, we are probably the only group to deliver all the products which manufactured by ourselves within our group. So we are committed with our customer to deliver the best technology and the best solutions for the market. And of course, we are working also with our customer currently under discussion is a perovskite. Basically, it's a silicon based tandem cell perovskites, these turnkey solutions as well. This is in combination with our sister companies under lead group under one roof. We have several cases are under discussion, and I'm here. I very much welcome our audience to contact Leadmicro, even to me personally, and we are very happy to discuss TOPCon, XBC heterojunction, as well as perovskites, these production systems, and especially for the future solar technology. Okay, so this is all my presentation, and thank you very much for your listening.
Thank you. Since I'm running out of the time, could you please stay back and answer if there are any questions in the chat window before we meet again for the panel?
Yes,